Hello everyone, this is Abhinay Chauhan from CG Artist Academy, and today I'm back with a new tutorial. And in this tutorial I'll be focusing on creating this kind of simulation. So this is what we are going to achieve today, and I will make this tutorial step by step. Let's get started. First of all, we will create a geometry node and we will rename it to Circle Water. First of all, we will create a torus. In the orientation, we will add z-axis, and in the radius, x should be 1, and in y around 0.15. Okay, this way, and its uniform scale should be 0.4. Rows and columns are fine. Next, we will create an ISO offset node. Let's connect this, and its uniform sampling division should be 100. So let's make it 100. Let's check. Okay, fine. Let's check the construction. Next, we will create point from volume. Let's enable this. Construction method should be sparse. Point configuration should be tetrahedral. Let's add a value around 0.1 maybe, or 0.5 maybe right now. Okay, that is fine for now. All the other values are, I guess, fine. Now we will create a circle, and that should be polygon. Yes, let's enable this, and here should be, this is fine, scale should be 0.4, the same which we had that for torus, and divisions should be 256, and arc type should be open arc, this way. Later we will add this in our pop solver. Next, we are going to create pop network. We need to add the first input, connect here, second one should be here. Let's dive into popnet now. Now let's go to pop source. Here we will, emission type should be all points, and this is fine. Use first context geometry which we have connected this. Now go to birth. In birth we will add an expression. Now let's go to attributes. Everything seems fine. Stream, binding, it's all good. Now we have to add another node which we will add in between the merge and the pop source, and it will be pop fluid. Let's connect this in between. Now let's go to pop object and go to collision, it's fine, and in physical, friction should be 0. Now again, let's go to pop fluid. We will change some parameters over here. First of all, particle separation should be around 0.005, and let's copy this parameter, and go to your particle points from volume, and we'll paste it as a relative reference here. Okay, let's go again. Constraint irritation should be 20. Constraint stiffness should be 10. Rest of the things I guess are fine. Viscosity should be 1. Now we will have to add pop curve force here. Let's add that. Let's change few parameters in this. First of all, geometry source should be use second context geometry, which the circle we have created. Now treat as when we should disable this. Your max influence radius should be 0.5. Individual forces should be, follow scale should be 0.02. Suction scale should be 4 and orbit scale should be 0.02. And inherent velocity, it's 1, it's fine. Now follow force fall off. Here we don't need anything, it should be like this. We don't need any fall off. Same here. Suction force fall off should be like this. Here also value should be 1 as well. Let's go to global force. In the force along length, we don't need this, delete, and like this. Shaping is fine. Now we will add pop force, and let's connect this like this. And we need to change some parameters. And amplitude should be 0.1. Swirl size also 0.1. Next we will add pop angle. Let's connect this, and in pop angle we have to add a vex expression. Basically, actually I'm following each and every parameter which gave me the result which you saw in the beginning of the video. Since we have added all the parameters, but first of all we are not able to see the particles, and this pop curve is not looking the way it should look. It should be circular. So first of all, to do that, just go back to the pop curve force, and in the guides that should be around 0.1. Okay, yeah, now this is looking better. And one more thing we need to do is go to circle and just disable this, untick this, reverse. And okay, now the next part is we are not able to see the particles. And why is that? Okay, the impulse activation I have added extra is equal to, by mistake, I'm sorry. Okay, now if we see, yeah, now the particles are visible. In the pop angle we have added this vex expression. So what does it do? The code adjusts the magnitude of the force applied to the particle based on the noise value derived from its position and simulation time. So imagine particle simulation where particle experience a wind-like force. The noise adds spatial variation, creating a area of stronger and weak force. The time-based noise introduces dynamic changes, making the motion feel more organic and alive. So that's why we have added this vex expression. Let's see how our simulation is coming right now. And let's simulate for 18 frames. So 9 frames I have simulated, and it's not coming the way it should. It should revolving around to this force, but it's not working. Okay, for this we need to change few things. First of all, go to in the pop solver, go to collision behavior, just untick this, add hit attributes, and in the pop curve force go to this shaping and resample curves, just disable this. Now again we will simulate around 40 frames maybe. Now you can see it's following the curve like this. If I go closely, you can see this is following the curve which we have created. Now what we're gonna do is we will cache this simulation. What you can do is add this node file cache and cache it out in your project directory location. I did this already, so I'm going to load the cache now. So I'm going to add this explicit, go to the folder, and if I add this, now you can see this is the cached particles and it's working perfectly fine. The simulation is just like the way I had showed it in the beginning of the tutorial. Let's remove the cache data, go to Windows, Cache Manager, and clear this so that we don't need any cache. We have simulated around 240 frames. Now we will add the time shift node, time shift, and I'll be needing, on my first frame it should be 100. So what we need to do is $F plus 100. That's it. Go to first frame, and if I enable this, so on the first frame I'll be getting the simulation kind of this, and that is what I need. Next, what we will do is we will add a retime node. So we want to make it look like a slow-mo. So let's add this node, and speed should be 0.5. We were giving it like a half a speed. Next we will add the particle fluid surface node. Let's enable this. Wow, it's looking really nice. Okay, let's make the particle separation value the same. It should be 0.005. Yes, now it's looking like a simulated particles. Voxel scale should be around 0.6. We are not going to crunch down the details over here. And adaptivity, we don't need any adaptivity. Now we have generated the fluid mesh. Okay, I like to cache the fluid surface in a BGO format, so I did the same with this. You can also do it, and if you don't want, you can follow whatever the process you want to follow. In this case I'll be getting my cache, so let's make it explicit here, splash mesh, and if you see, this is my mesh which I have exported as a cache. Now I will need the more smoother mesh. So to do that, one thing you can do in the particle fluid surface, go to filtration. You can add these filters to make it, but in this, if we do this, we will lose some quality. So I'm not going to do that for this, but in some cases it works. Here I will add the normal node, and here we'll be adding the points and by face area. Next we will add attribute blur, and in this attribute should be n. Blurring iteration should be 5. Yeah, 5 is fine, depends on your requirement. So if I enable this, you can see the difference. Without losing quality, I just smooth out the smash, and it's looking fine, it's looking good. Now because we are going to light it or shade it in Maya, so let's create a raw alembic output. Here you can specify the path. I have already exported it, so yeah, that's how you can do it. So now this is done. Okay, now let's rename it properly, water. Next, we are going to create the bubbles. And for bubbles, it's pretty simple. Like, I have created another tutorial which is liquid flow, in that we have followed the same thing. Let me show you in the main file. So this is the bubbles. Here I have loaded the same particle cache. In that I have added the same time shift node, then this retime node, and after that I have added this wrangle node. The same code I have used to randomize, and the percentage of points I need from the particular simulations. Then I have created a sphere. That's a basic sphere, nothing much. Then there is a node called copy to points, and you can see these are the bubbles. Again, I have exported this as a Alembic for Maya. So this is done. We are done here in Houdini. I hope this is very straightforward and simple things to follow. And I have also added the Houdini file for your reference. You can go and check that out. Okay, let's go to Maya. So we are here in Maya. First of all, we are going to import the Alembic geometry. Let's import. So first of all, I'm going to add my splash. So this is the splash. And again, let's hide this. And next I'm going to import my bubbles. Bubbles are also imported. So that's how easily you can import your cached out Alembic meshes in Maya. For the camera creation, it's fairly simple. Go to camera, create camera. Let's rename it to main cam. And this process I follow. Let's just put it here somewhere. And now let's create a locator. Let's cam controller. Let's drag it to parent it. So now this controller will be, so with this controller you can animate the camera and the kind of angle you want to achieve. It's simple as that. So these are the few simple things which I have created. And same with Arnold, I have created the HDRI. For HDRI, let's go to lights and sky dome light, and in this click on this button, go to file, and here you can add any kind of HDRI or HDRI image you want to add for this. So that's the very basic how anyone can set up their scene in Maya. So let me go to the main file. Like, this is the main file which I have created. I have followed the exactly same things. So these are the three cameras I have added. First one is this main camera, this one, another one is like close up, and the third one is macro. It's simple, nothing much. Then in the Arnold render settings, I have I have added file name prefix to scene, then camera, then render layer and render layer. So it will create the folder like this: the scene file, the scene file name, then camera name, then render layer, and then render layer name. Okay, here I have added this merge node for the AOVs, and here you can add the frame range, whichever range you want to render. In this renderable camera, I have rendered the HD output, and the samples I have added not much samples here for the anti-aliasing samples, diffuse 2, transmission 4. That's it. Nothing much. I have added Z-depth pass, diffuse direct, diffuse indirect, specular, and transmission. That's it. Nothing much. And I have added these render layers for this, like beauty layer. In this I have all the cameras, and then this the collection, which is circle, water, and bubbles. Then there is a BG, which is this. Then again background separately, and then a matte layer. For the BG I have added this absolute override like this. You can add absolute override like here, so that I can disable the visibility in this particular layer of the background. Shaders are also very simple. For the bubble, I have zero base weight, specular without roughness, IR around 1.520, transmission is full, and that's it. And for the water, I have added this index of refraction 1.33, which is the index of refraction of water, transmission weight 1. Then I added this color and added some depth. Why I added this? Let me show you. If I go to render view, let me just click on this update full and go to main camera, render again. And for the particular scenario, let me add this background. Okay. So if I select this and go to my material, if I put the value of 0 here, you can see this all blue. So if I add the depth, it looks like this. That's how the real water works, because of its transmission refraction values. That's how it works. So that makes a cool look. And I have the 3 camera setup. So let me go to this close-up cam. This looks like this, then this, and this completely based on your requirement. The look you want to achieve, you can make it like look like a chocolate, look like a milk, look like a crystal clear white water, whatever. So that's how I created the water circle effect in Houdini, as well as rendered in Maya, and the final look was like this. I hope you like this tutorial, and I'll be making some more tutorials really soon. Till that time, stay tuned to my channel and updates. And if you have any query, if you have any issue, you can comment on this particular region post in which I have uploaded the project files, as well as on YouTube. So I will respond on that as soon as possible. Till that time, take care, keep your families and loved ones safe, and have a nice day.